And on this edition of the Open Alliance Show, we're going to be welcoming in 7407 Wired Boars, who, if you followed them from last year, was one of our most popular and featured teams here on Open Alliance, and this year doing an absolutely phenomenal job as well, too. We'll be talking all about their different prototypes, including this awesome 1/5 scale model that you saw on screen, their different CAD progresses that they're doing, and programming as well, too. This team, absolutely phenomenal. You're going to hear about how they're approaching the trap and doing this full integrated climb with the trap as well, too. Let's learn more about them here on the Open Alliance Show. This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineer their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship, providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Coming into the Open Alliance Show, please welcome back one of our featured teams, and definitely one of the teams that I think was the most followed last year, 7407 Wired Boars, coming in from Connecticut. Welcome, everybody. I know we got a lot of people on. Let's introduce everyone.
Hi, as we said, we're 7407.
The Wired Boars.
Everyone will introduce themselves very shortly. We're going to rotate on and off, but we're really excited to show you our prototyping, our programming, and everything we have for this awesome season.
I'm Max. I'm a CAD designer and shop manager.
And I'm Asher. I'm a CAD project manager, and I'm on technical documents. And we're going to be telling you all about our prototyping for the intake.
So we're going to be talking about our first prototype. So in our design, we want to prioritize variability, so we could test lots of different roller sizes, compressions, and angles. As you can see in the video, we had our shafts in slots that could move on the X and Y axis. That let us test different compressions and angles and let us vector it upwards. Also, the setup was screwed into 2 wood blocks, so we could move the height off the ground and see how that differed.
Yeah, this also lets us try different wheel sizes, which was very helpful in the end result. And as you can see, it vectored pretty well, which is exactly what we wanted for a good handoff. Next thing we did, we made it a little bit more game-like. So we made it so we could intake from the edge of our frame and get it to the middle of our robot, which is where we thought we were going to be doing our intake shooter handoff from. And we have a over the bumper set up here, and that way we have more a more length to like pick up game pieces. And we have rollers here covered in rubber, and this similar setup to what was in the previous prototype, but with 4 wheels to help vector it up correctly, and a little ramp here to make sure that we can dual intake from either side if we so choose and help vector it upwards. We also have this pan underneath so we could intake a piece and drive with it, not fully in our intake yet. And we added a small roller at the bottom here to help transition from the floor to that pan. In the next, I'll show a video of how that one worked. It was pretty good. We liked it a lot, but we know we could improve. So our next prototype, it consisted of some small changes, which included cutting the pan on the bottom back and moving the bottom roller that helped transition from the floor to the pan behind the first roller to help transition from the floor to the pan easier. And we also added these passive rollers here to help vector in from the sides, because we noticed that when we fitted no off center, it gave us some trouble. So we also changed this front roller here from wheels to tube, and we also covered it in silicone. And we noticed that when the silicone was angled downward at the edge, it would help vector it inwards. So we kind of mimicked this effect by cutting off the silicone from the edges of the tube and wrapping electrical tape where it wasn't to keep the grip, because it was pretty slippery. And it ended up really working great for us. And even from the side, it was able to vector perfectly and go straight up, which is what we wanted. However, as things go, things change, and we ended up needing not to intake and hand off from the shooter from the middle, but closer towards the edge of our frame. So part of our roller design went away, but everything else is pretty much the same except for the angle. We still have our bumper roller over the bumper, and here we still have our ramp, but instead of having the transition from the floor to the belly pan, now we just have a shaft transitioning from the floor to the ramp. And instead of going straight up, we put a wheel here to help vector it this way. And that's about it.
Asher,
that's where we are right now.
Asher, if you don't mind me asking, when you looked at your initial strategy for how you're approaching Crescendo game, did that end up changing at all based on the prototypes that you've seen, or are you still able to stay true to where you were at so far and just modify those prototypes in CAD just based on the results that you've seen?
I know that our initial prototype was very motivated by something else we've seen from a different team. I can't remember which one, but we saw someone be able to pick up a piece from two shafts with wheels on it that were completely horizontal to each other, and we were really hoping to mimic that, and we were able to, which made us very happy. But we ended up changing it slightly just to work a little bit better for dual intaking and for speed.
Well, I'm very excited to also hear about your shooter prototypes and what you've been doing for that. I've been following along with your OA blog and what you've been doing for that. And there's a whole bunch of different videos I know I've seen out there. So show us where the progress is for that.
Yeah, absolutely. I'm going to hand it off to the shooter prototype people.
All right, so initially for the shooter prototype,
Well, yeah. My name's Anakin, and I'm one of the electrical control system project managers.
And I'm Ethan, and I'm a CAD project manager.
All right.
And so initially our shooter prototype began with 2 aluminum tubes. They were 2-inch diameter, and they were top and bottom rollers. And what the problem this caused was, because there was constant compression throughout the whole note, this caused the note to sort of knuckleball through the air, which is not what we wanted, as well as when spun at high RPMs, this would cause a lot of vibrations, and it was bad for our whole shooter accuracy in general.
Yeah, so as a result, we switched to 2-inch horizontal compression and 1.5-inch vertical compression. And so as you can see in this video, this is what happened.
And looking from this type of prototype, when you were analyzing different ones, and like I said, watching your videos, I've seen a few different directions you've gone. Are you accomplishing essentially what you're looking at from an objective standpoint when you went with this type of shooter, or is there still more work to be done with it?
Yeah, so our initial prototype, or the current stage we're very happy with, because what we've done is we're taking, like Anakin mentioned, we're taking Fairlane wheels now, and we added spin to the note, so it's extremely accurate. I think the other day we shot 20 for 25 shots, so our prototyping is currently working. Yeah.
And yeah, I mean, and that also caused more contact time on the right-hand side, so it induced more spin and made our note fly a bit more smoother and straighter, and also allowed for more rotational inertia and more accuracy in general. Yeah, and then, I mean, we even were able to limit the rocking motion of the shooter itself, because earlier we had that issue.
Yeah, and so on the shooter, we have Fairlane wheels, as you can see in the video. We have 4 Fairlane wheels with 4-inch diameter, and they have 1/2-inch vertical compression as well as 2-inch horizontal compression. And then we're going to change that horizontal compression. Currently, we're using wood beams, but we're currently changing that to be sushi wheels. And then we're going to use that to feed it into the shooter to try to test the indexing.
So you're going to have like a row of sushi wheels essentially on each side, or how many are you looking at doing?
Currently, we're testing 2 on each side because a row would cause the whole shooter mechanism to be very heavy, and we're trying to make this mechanism as light as possible. But that is subject to change.
Yeah, and then we also my bad.
No, go ahead.
Yeah, and so I was saying we also figured out that feeding is really important. So even a slight change in how the note is fed through our shooter caused differences in direction and just in accuracy in general.
No, that's exactly the question I was going to ask, is how are you planning on getting the notes to that area? And one thing on top of that too, we've been hearing from so many teams the wear and tear that takes place on notes as well. Have you put any in consideration in regards to how you're gripping onto this, and have you noticed or done any tests with notes that are maybe still good for the game but have a lot of chunks out of them, so to speak?
Yeah, so our current prototyping options for like indexing are, we're either using side wheels, we're going to do a top and bottom roller, or we might even use belts. But we're currently testing that. We haven't gotten that far yet.
Yeah, we've even started to notice on our notes the wear and tear. So we're strategizing different ways to combat that.
So what are a couple of maybe next steps coming up in the next week or so? What are the immediate things that you want to get done from the shooter prototype side?
Yeah, one thing is we definitely want to finalize our indexing system to make sure our shooter is as accurate as possible. And we want to finalize the shooter geometry to make sure we're shooting as accurately as possible with our given setup. And yeah.
Well, thank you so much for telling us more about that. There's so much more to cover in this robot, including what's right next to you all too, and that's the mini climb. I believe that's a prototype for that, and we'll be going into the elevator CAD as well. So let's hear more about what's been going on from that side of things, and show a bit more on screen.
All right.
All right.
We'll pass it off to these guys.
Hello, my name's William. I'm a CAD person, and
I'm Huber, and I'm a control systems manager, CAD team member, and I do all our OA stuff. So what we have to talk about really now is the mini climb, the elevator CAD, and the architecture. So last year we went with a really, really complicated design. Obviously, it was basically a pink arm that could extend it at a wrist. This year, we didn't want to do that. We wanted something simple. So we decided, and then at the beginning of kickoff, right, we had this big decision to make. Like, we wanted the shooter to basically be able to go up and down to shoot over defense. So we really had to come to a decision, what could be the easiest thing to do? So basically, we decided to do an elevator because compared to an arm that is like double jointed or something, this is a lot simpler and easier to manufacture. We have a lot of experience with elevators, and overall, it's just easier.
okay. And also, the great benefit with this design is that we can trap. So with this design, we can shoot from many different distances, shoot while defended, we can shoot into the amp, and we can trap, all of these 2 degrees of freedom. So as you can see with this mini climb model here, how we actually trap is that we have 2 hooks. One of the hooks on the 3rd stage of the elevator, and one of the hooks just static on the bottom. So what we do is we drive up to the trap, which is great because this means that we don't have to line up with it. We just go, we drive up to it, and then we make our elevator go downwards to hand off to the bottom hooks. And at this point, we have this tent mechanism here, which flips out a bit like an intake. We're thinking that it's a single flip out design, but we haven't really designed it yet. And what it's able to do is make the robot go and tilt in front to get into the trap. And so this allows us to have our center of mass in the back and then still be able to tip forward. And this is our design for how we're going to trap.
We've heard so many teams, big Chief Delphi threads about avoiding the trap. Don't go for it. When your team was looking at analyzing this game, what made you say, yes, we are going to go for the trap? Because I love the overall concept design. This looks great.
Well, we looked at how we could get endgame points and that ranking point from endgame, and we realized that if we have this trap point and we have another partner that can climb, we're almost guaranteed to get that ranking point, which is going to be really important during quals. And so that's why we went with this design. We thought that if we could incorporate it without any extra mechanisms, then that would be super, super great. And here we have it, and we even mocked it so that we could tell, like, hey, do the physics work like they do in the motion studies, and the geometry of this trap, the tent mechanism down here.
No, I love that you've done that mini model there, and that's something that I wish more teams would do for something like that, because you get a lot of that experience of seeing what that's actually going to be like from an interaction standpoint. Is that, when from advice to other teams on that, like, how do you go about approaching actually building something like that for other teams who might want to say, hey, we want to try something like that too?
Well, I think the main focus that we'd had on this design was getting it done really, really fast. So it's laser cut, it's 3D printed on our Bamboo Labs, like ludicrous settings. So the print quality isn't great, but we were able to get this done in like a day. And so we were able to do that. The linear slides are kind of these shafts. And so being able to use these materials, and this is a 1/5 scale model, so making it small, we were able to make this design. And also the point of this design was to get this trap geometry correct. So we have this adjustable trap geometry, which we can use to then put into our actual design and figure out experimentally what our trap geometry is supposed to be.
Your team, every year we've had you on the OA show, always brings like this little extra secret sauce to it. So I love that you've done that as well too. Before we move on into programming and getting some updates from there, was there anything else from a CAD side that you want to talk about in regards to your elevator CAD?
Sure. I mean, obviously we decided to make this trap basically mock up really fast. So what it allowed us to do is complete the elevator CAD. It's fully completed at this point, which means Now we're into manufacturing of it. So we're hoping by the end of or the middle of next week to have it fully done. And this year we're building 2 bots. We're building a mirror bot and then we're building a competition bot. So the first mirror bot is just really rough. We're just trying to get it done as fast as possible. And these little prototype things like the trap mechanism allow us to move really fast. I think that's something that we're really prioritizing this year.
Well, this is an awesome update, and I love to see everything that your team has done so far, but we cannot leave programming out. Your team has done such a fantastic job last year, so I'm excited to see where you're at this year from programming updates. So let's bring in our next set of students to educate us a bit more on what you've done. And I'd love to hear, of course, how when you take strategy and implement that into your autonomous and the rest of your programming for the entire match, how that all kind of meshes together for you. So welcome.
What's up? I'm Cyrus. I'm one of the programming project managers.
And hey, I'm Sebastian. I'm another programming project manager. And yeah, we're just here with another update. Yeah, okay, there we go. There's a slide. So first and foremost, the first thing we always want to say is, well, real quick, we're a Python-based programming team, which is also it's really great that Python's been an official language this year. And it's just something that we want to highlight to all teams in case they need any aid or any resources and any of that. So we have our GitHub link there. It's probably not going to work because you're watching a video right now, and I didn't really think that through, but it's okay. It's probably in our OA. It is in our OA link in the Chief Delphi. But yeah, that's it from me. So you want to talk more about how we're doing this year?
Our development process is similar to how we've done it in the previous years. We're doing subsystem testing and commands, but one of the main new things that we did is added in rigorous testing. This is so we can make sure all of our code is perfect before we get it into dev. We're using PyTest and MagicMock to efficiently test our classes and our subsystems without actually having to have the hardware. So this will prevent us from a ton of bugs once we actually get the actual hardware. And so far it's been great.
Yeah, we have our, you can see in the bottom left corner, we have our sacrificial robot it's basically it's a swerve bot, really small. I think it's like 24 by 24 swerve pods, limelight, and just that's our sacrificial one. So we sort of just, mess around with that, see what works, see what sticks, lets us tune our Falcons and hopefully our Krakens when we get them for driving. And yeah.
Can you talk to me a little about objective-wise, both from autonomous and then in teleop as well too? What are you looking at trying to accomplish in autonomous, and then in teleop from a programming side? I see you're doing vision obviously as well, but like in object detection especially, like what are you actually trying to accomplish from both sides of those aspects?
Yeah, so that's a really good question. We're really trying to make a lot of things more automated this year, and yeah, the two things are autonomous obviously, and then teleop. So especially for our autonomous routines, our main objectives, at least for right now, is to make sure we have some good autos working on the wing side and then on the half line side. And then we're looking towards more configurable autos this year or pre-configurable before each match, because we really think that especially at high levels of play, it's going to be a very custom match where you might want to have different autos to complement different robots. Or, like in the bottom right corner, we have note detection. So to detect notes so that, like, let's say we're at the half line and, another opponent robot steals that. We don't want to go and grab an invisible note that doesn't exist. So being able to do that really, really effectively will help us maximize our points, especially in high levels of play. And then speaking more onto that, we actually do have an update more on our shooter algorithm flywheels. So this is with the special help of Eric. He's behind the camera right now. You can't see him. He's waving right now, which is really cool. But we have a couple of things that we wanted to talk about specifically for the shooter. So the biggest thing was that we wanted to fire this thing at max speed. So more power, big, fast. So we have been developing some differential equations on, getting the maximum speed at the right angle with the different odometry. So we've been sort of in the process of that. So this is our first iteration. I think we've definitely improved on it. So now we're adding air resistance with simulations now. But this is going to be a really big thing that we really want to work on so we can get those really far autos, really far shots. I mean, obviously we're not going to know how it's going to look like until we actually, end up competing. But being able to get ahead of that curve is a really big push for us.
Well, Wired Boars, thank you so much for taking time to tell us all of your updates you've been doing. one of my favorite OA blogs out there, so make sure you are following them on Chief Delphi. They have their GitHub on screen up earlier as well, too, if you're interested in that aspect. But we can't wait to see how you continue doing. We'll be checking in with you in just a couple short weeks. So good luck the rest of the way, and thanks for showcasing your progress so far.
Thank you for having us. Yeah, thank you.
This video on fun is brought to you by viewers like you and also in partnership with the following. Discover how Kettering University students engineered their success with Kettering's amazing co-op employment programs where students earn great pay and gain valuable experience. Those accepted into Kettering University can apply for a robotics scholarship providing up to an additional $5,000 a year in tuition assistance. Head on over to kettering.edu/first to learn more and apply. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.